Welcome to the Requirements Working Group meeting. Wanted to see if we have any announcements.
This is Louis Crouch. I do want to make an announcement that the Guide to Writing Requirements, the final version has been created and provided to TechOps. And TechOps is in the process of getting the document ready to put it in the INCOSE store. It's referenced in the new version 5 of the System Engineering Handbook. And so it's important that we get that in the store at the same time that the System Engineering Handbook is going to be released just prior to IS.
Excellent. Thank you. Nice to see that it's coming out right before IS. So,
are there significant changes in it from the current one, particularly in terms of the characteristics?
There really is quite a bit of change. Section 1 has been updated to agree to our other products a little bit more. Characteristics-wise, we added one new characteristic for sets. For some reason, we didn't have the characteristic correct in the sets. We had it for individuals, so we added that. And then we've tweaked the wording for the rules. The titles of the rules before were kind of confusing, so we came up with real titles for each of the rules and a description for each of those. There's a lot more emphasis on patterns and templates, use of conditional and qualifying clauses throughout. The examples have been updated considerably. We got a lot of good comments from the reviewers. The Guide to Writing Requirements really should be called the Guide to Needs and Requirements. Some of the rules are more applicable to requirements than they are needs. And also some of the rules are really dependent upon you having a project-defined glossary or data dictionary. And so there's more emphasis in that. The reuse company produced a table, which is Appendix D, goes through each rule and says which one's more applicable to requirements versus needs or both, and also which the rules have a dependency upon having terminology well-defined. And the fact that the terminology that's defined for the project, you want it to be consistent across not just the requirements, but all your system engineering artifacts. So if I talk about a function name and a requirement, I should be using the same function name in my models. And the same for entities. So it's quite an update.
All right, thank you. So I wanted to go ahead and get started on today's topic. So I'd like to introduce Dr. Steve Dam. He's the president and founder of the System and Proposal Engineering Company, also known as SPEC Innovations. It's based out of Virginia. He's been involved with structural analysis, software development, and system engineering for over 40 years. He participated in the C4ISR Architecture Framework, now known as DoDAF, as well as a business enterprise architecture and Net-Centric Enterprise Service architecture. He's currently applying system engineering technique to various Department of Defense and Department of Energy projects. Dr. Dam is the author of 4 system engineering-based books, including the most recent, Real MBSE, Model-Based Systems Engineering Using LML and Innoslate. He has a BS degree in physics from George Mason University and a PH.D. in physics from the University of South Carolina. He's also a INCOSE certified ESEP. So I'd like to hand it over to you, Dr. Dam, to be presenting Applying AI for Requirements Development.
Thank you. Appreciate it. So, by the way, I've been aware of the Requirements Working Group for many years because I've been involved with INCOSE since the early 90s. And it's funny, I've not had time to get to one of your meetings over the years. All the working group meetings, things like that, I'm always being dragged into so many other places. And it was Tammy giving a presentation at the CAB meeting. So that was kind of a big aha to me that, oh my gosh, you have this great guide and all these other things going on. So we've spent some time looking at the guide, and we had actually, and I'll get into this a little bit later, but we'd been using requirements quality for quite some time. I taught it back in the early 2000s for what was called then NEMA, currently the NGA. We used a set of criteria that I'd learned from Ivy Hooks. I'm kind of getting ahead of myself a little bit with my slides, but I think it's kind of interesting. So I'm kind of interested in this becoming a really good dialogue, because we're really excited about what you're doing and how we can automate it. Because, of course, a lot of our goal is how do we make that job easier. You have 41 rules. It's a lot of rules to track. So that's not something a human's going to track real well. We're going to need help. Anyway, so let me jump into the agenda here. So we're going to talk a little bit about what we mean by artificial intelligence, because I think there's a lot of confusion about what it is and isn't. And then talk about how to determine requirements quality, how we currently do it. And then talk about how we can also ensure best practices for requirements development, because there's some interesting work that's been done there. And then talk about traceability, because of course requirements traceability is one of the essential elements of what we want to be able to do. And then talking about how we separate the needs and objectives currently. And again, I want to think a little bit more about, you have a little bit different way of looking at it. And I'm kind of excited about that and want to think about that. So some of the future work needed, particularly from an analysis of your documents. And and by the way, I'd love to get a draft of the new one, so we can make sure we're up to speed on that. And then we're plenty of time for Q&A, and I'll walk you through what we're doing with it, so you can see a little bit more, and hopefully that'll help understand. So let's jump in. What do we mean by artificial intelligence? AI is basically the ability of machines to perform tasks, okay, that normally humans would do. And there are a lot of areas they can do it in. There's learning capability, problem solving, decision making, pattern recognition, things like that. So many different forms. And in fact, there's several branches of AI are under investigation and use for requirements development, including machine learning. So that's actually a way to get to look at the words being used and how they're used, and then ultimately the idea is come up with algorithms, which then form another part of it, which we'll talk about in a second. Another is computer vision. Let me jump back 1 second here. So you notice there's lots of different types of machine learning. Unsupervised, supervised, reinforcement. So they've got all these sub branches that they've created in this area. So some things work well for some areas and work better for others. And a lot of times it depends on how big your data set is as well. So that's another factor in this activity, machine learning. Computer vision is something where, it can distinguish key things in a picture, and that's an interesting area. Not clear how that works with requirements so much, but it's an interesting area of progress. And of course, probably the one you're most familiar with is natural language processing. And machine learning is usually used to help derive the algorithms we used for natural language processing. And then you see kind of the sequence of the pipeline for natural language processing. Basically, I'm more of an end user of this process. You usually pick up NLP libraries to use for this purpose, but we've also been doing some basic research in both machine learning and NLP development. So our company has been under a NASA contract. So how do we determine requirements quality? We apply the rules to assess the quality of the requirement. So basically, the rules can come from a variety of sources. Guidebooks, of course, you guys have a great set of rules. Standards, there is the lifecycle modeling language has actually a standard out for this. That includes that. And then best practices. So this is some work done by Dr. Christian Giammarco. If you're not familiar with her from Naval Postgraduate School, did some very interesting work in best practices for systems engineering. They came up with 68 heuristics, mathematically expressed quite a number of them. So let's talk about those a little bit more. So requirements quality, again, this was originally derived from work by Ivy Hooks. And so again, National Imagery Mapping Agency back in the early 2000s, using that as part of what we did for our systems engineering courses that we were teaching there. The key is that it's used as an example, and it's not a mandatory language element in the LML standard, but this was suggested as a set. And so this was the set we worked to. I think what we implemented in Innoslate was 8 out of these 9. I think the modular one got wrapped up in something else, if I remember correctly. So we ended up consolidating a little bit, because there seemed to be some overlap between these. That's one of the hard things about these categories, these types of things, is keeping them separate enough that they really are distinct from one another. I did notice that being a difficulty as well. So this has been in the specification since 2013. for LML. We implemented it in NLP. I want to say it was like 2015. It was very soon afterwards. And all this was very new. NLP libraries and things like that were very new. And we're actually at a point now we're about ready to upgrade all of this. So this is actually very timely for us to have this discussion. Best practices, again, this was the work by Kristen Gianmarco. Basically, the formal rules were derived from analysis of best practices. Again, the 68 heuristics in total. 9 are specific to requirements, and there are 5 general ones. So that applies to any class of information, and it also applies to requirements, of course. And so you can see the kind of thing for the traceability axioms here. This is some of the things specifically trying to help enable better traceability. So you can see this, and if anybody wants this paper, I actually did find it again on my hard drive. So glad to send it out to anybody who wants it. Again, we've implemented the entire 68 heuristics in Innoslate's intelligence view. So we have that as well in the tool as an adjunct to what's in the quality parameters that you saw in the previous set that we implemented from LML. And again, you recently updated the guide back May 2022, but again, it sounds like there's a new one coming. So I'm excited about that. And so there you've identified 9 characteristics for individual requirements, 5 more for sets, and the 41 rules associated with them. And we spent a fair amount of time trying to map the set of rules and characteristics and things to what we do currently in the quality checker and in Innoslate. And the next slide has our attempt at that mapping at a high level. You can see at least the key characteristics. So we do have coverage of the basic characteristics in our categories, at least I'd say, again, 8 out of the 9. Conforming was one we weren't quite sure. I'm not sure how I would implement that in terms of the NLP checker. We do have a couple of them already that are not automated, correct, and feasible. And so those both seem to be difficult to do in a full automation. But I think your rules might help us with some of that. So again, I've always been hesitant, though, to give anybody a complete 100% score, because they'll just say, oh, well, the tool says it's 100%. And they won't read the requirement. So I'm hesitant to not have. I will definitely have at least 1 or 2 manual checks, because otherwise nobody will actually read the requirement, and then that'll cause bigger problems downstream. I can see the lawsuit coming, actually. But by the way, we have the ability to extend the list of characteristics that are used for the quality score. So that can be added very easily. I can show you how that's done today. So I'll actually add that and show you. Anyway, so this has been a mechanism. Again, we view this as an aid to requirements analysis. It is not doing requirements analysis for you. I think I always try to foot stomp that. Tools are tools. They're there to help us do the job better and faster and cheaper, hopefully. But they're not a replacement for human knowledge and wisdom and experience. So you're not out of a job anytime soon. AI is not going to put you out of a job. So don't worry about that. So how can we ensure the best practices for the requirements? Again, this is where we've implemented the intelligence view and implemented the NPS heuristics in the database. This actually reads every element of the database and is looking across these different criteria. The little panel in the middle you see is the actual view you see from Innoslate, and it'll roll up, and you can adjust this view so you can determine whether these are errors, warnings, or just ignore the thing. So you do have some tailorability with that. The full set of things here on the right, you see that list is the full set. I don't think if it doesn't find anything, it gives it just doesn't show up here on the list, because this is the list of the items that have the problem. And so again, that'll be more clear when I show you the tool itself and how that's used. It appears to me that the set characteristics is something that would have to be scanned for the entire artifact, which incorporates all the requirements in it. And so that's something we might want to do and actually add those, your C10 through C14 characteristics into the artifact class as a mechanism for look at the quality of the artifact overall. So that's something that kind of new to us as an idea, and I think we're very excited about that, maybe being able to implement that. So the next thing was traceability. How do we ensure requirements traceability? First of all, we have a documents view. This actually looks at it and will present it like a document or a table. In this case, you're seeing a portion of the table where the rationale field that's part of the that is part of the requirement does show up here on the right. We have indicators for that the primary traceability requirements have been met. I don't know if you can see or not, but there's a little S, T, and V. And so those are indicating that a satisfied by, traced to, or verified by, and verified by relationship in this case, and that first one, have all been made. And so I instantly see my traceability has been established from that view. That's just one of many ways you can see traceability in the tool. Another is the traceability matrix. This is a way to interactively create the links between the different views. So this is actually looking at my verification requirements in the rows, and the columns are my test cases. So I can trace directly those. And if I hover over a cell, the name, number, description shows here on the left panel, so I can see it. And if I click in any of the rows or columns, I can actually edit that information directly here. So this is a way for you to really build better traceability. And then this is another place where we've added NLP. So we actually have a suspect assist and a traceability assist looking at the information and trying to see if they fit together. And again, it's NLP, so it's looking at verb forms or word forms. And so it can overlap things and see how much commonality there is between them. Oftentimes we'll see a very heavy red indicates that it doesn't find anything to make the connection. And that may just be because in this case, particularly the test case isn't defined or doesn't have that information in this procedure. So it's being checked. And so that's why you see probably a lot of red here. There's a lot of work to be done. And so that's again, a nice tool for you to indicate that say, hey, yeah, I've got a lot of work to do here to make this right, and add that value from the beginning. Another thing we've been advocating, and I think this group's been advocating it too, is that when you write the verification requirements, you ought to go ahead and write the test case as well. That way you know for sure that it's verifiable. I'm not sure how you know otherwise, unless you've actually been able to write at least a draft test case that has the feasibility to be verified. By the way, we use the term test case. It's any kind of V&V. It's not just testing, just to let you know. So how do we separate needs from objectives and requirements? So in our import analyzer, we have the ability to separate. We have them in two different classes. We have statements and requirements. And our statement class doesn't have all the attributes that the requirements does, but they can easily be added to it if that's desired. And so that's a way we can separate using keywords, the shall, will, must, should, whatever you want to put in there. You can go ahead and make it so it'll separate for you as you do the import, and it'll create them as statements or requirements. Currently, our way we look at goals and objectives, we have labels for statements that are in the statements only place. So again, if it looks like you want to have those keywords being part of your needs, for example, I think is the way I read your document, it appears to me that that would be a type of requirement. A need would be essentially a type of requirement, the way we have it laid out. Or we can create a subclass of statement that's needs as well. So there's another way we can handle that with it. Again, all of these things can be added to the schema as you go through and can be extended as you need to, tailor it to your specific approach and needs. So that kind of leaves me with the future work needed. clearly, since the rules and attributes you have from INCOSE are new to us, we want to make sure we take those on board and see how we can use them to enhance our current NLP algorithms. And so that would our checks. And then that would give us a lot more breadth there. I actually love to do that. And then adding additional INCOSE characteristics attributes as needed. I think that's something certainly can be looked at. And another thing was adding that set of requirements, characteristics intelligence view. I think that sounds like a good thing to do. And finally, one of the things we're looking at is looking at other forms of AI to apply requirements development. So one of the things everybody's looking at is ChatGPT. It has some very interesting technology options as well. So we are exploring how we would interface with that and where that might go in the future. So we might have some interesting things for that by the IS even. That's kind of our goal. So let me kind of go through and show you a little bit of what I'm talking about in the tool itself, because I think it'll make a little more sense. And then we'll have plenty of time. So the dashboard here is for a model. This is actually just a demo project, so it's not too important, but it's based on a set of books, Applied Space Systems Engineering, SMADS. Are you familiar with those? They define the FireSat model. There are ways to build summary tables and things like that that are just kind of capturing some aspects of it. First of all, let me show you the import analyzer. I mentioned that earlier. So we have a very nice Microsoft Word docx importer. It does require that the style headings are being used in Word for the numbering. If you've got a PDF and you save the PDF as a Word file in Adobe Acrobat, this will import very nicely that way. It'll pick up tables, it'll pick up graphics and everything. Here's the knob to differentiate between them. So if I want to have my general statement class here, and then I'm going to make requirements be the class here that has these certain keywords. So here's where you could add should if you prefer. If you don't like them and you just want shalls, you just X these others out and get just the shall. Again, it's very tailorable as you import it. If you have it coming in from a table, we have a nice CSV kind of import as well. So that's a good way to bring it in. And it has that same feature of being able to separate between them by keyword. Also, we do have a nice recif import and export capability. So you do have round trip capabilities with recif as well. So for requirements, we've got a number of different ways to bring data in. We also even have a plain text import. So if you are still in that situation. So I think you'll find this is very nice. One of the things that we do, the reason we're so big on these hierarchies is that we automatically use the numbering scheme to create parents and children. And so that helps you a lot in terms of working with the information. It doesn't bring it in flat. So you can actually see it in a document kind of form. And so now, let me give you an example, that verification requirements document we were looking at earlier. You can collapse it. So if you have a very large document, you can use this navigation to collapse and adjust things. You can also use this, by the way, you can drag and drop here within this hierarchy sidebar. So that's also something that's helpful. And then here I mentioned the traceability relationships, the SD. So you just click on it and you come over here to the relationships tab and scroll down and you see the satisfied by, traced to, and the verified by are the three main traceability relationships. Of course, we have the language has many relationships between classes of information. So we look at the whole thing as traceability, not just that. Also, you can see this in other forms. So if you'd rather see this as a tree diagram, you can do that and expand the tree. And so this is very nice because this is a great visualization tool that will let you see the requirements and expand out the nodes of them. And you can have a very, very large diagram. This can be a very large diagram. And we really design things to scale. For example, we just updated this view, the documents view for infinite scrolling. So now you can have very, very large documents available within it. We had one customer who wanted to be able to access 10,000 requirements in a single document. And before we were doing what Microsoft Word does, which is load the whole document into memory. Well, 10,000 requirements, you're loading for a while. And so performance gets to be really bad. And you couldn't enable things like drag and drop, and you couldn't do a lot of things that we can do now with this. By the way, there are baselining features and things like that as well. There's lots of other requirements kind of focused things. But we're talking about the quality score. And the quality score comes from the set of attributes. And if the tool is finding issues with it in the quality checking, it'll give you these hints about how to make it better. So you'll see finds ambiguities, needing to split sentences, things like that. So this is very helpful. I've had a number of students particularly comment how this really helped them understand requirements better and how to write a better requirement. So I thought that was kind of nice to hear. We use labels for sorting and things. So if I want to see how many of my requirements here are checked by analysis, I can do that as well. So just lots of features in here. I'm not trying to do a demo for you of all the requirements features, but there's a lot in here. But that's kind of how the AI particularly comes into play again here in the quality score is the main place for that. The other thing I wanted to show you was intelligence view. I have plenty of time for questions here. So this is, again, a toy problem, so I'm not surprised I have a low pass rate, obviously work in progress. But here's some of the global analysis requirements that are here. And again, easier to see the entire thing here, all the description of what it is. It's pretty wordy. I'm sure this looks familiar. Some of your rules were pretty wordy, and that's okay. That takes a lot of words to describe what you're really doing. But this is where you can set it as a error warning or ignore it. So if again, it's not something you care about, it's not an issue for you. So it rolls up those scores, you see where there are problems. And then if you see a thing like there's duplicate names, that's a common problem. But you may have accidentally done something twice and you really only want it once. So you could hit the fix button and merge them together. So things like that are available, and it merges all the information together. And then here's that requirements panel down here specifically. And again, I can go find out what ones are not using a shall, what requirements are not at leaf level. Now, again, this is looking, I believe this is a leaf level. Yeah, leaf level requirement. So it's going down the hierarchy and trying to find the leaves, and you'd have to go click on them and go fix them. So it'll take you to the entity directly, and you can go in, and again, it gives you things about talking about kind of good structure, how to write the requirement better. So anyway, that's kind of a quick thumbnail of what we've done and what we're trying to do in the requirements area and with AI. So I think I got plenty of time for questions. So I wanted to leave some time for questions. Is there any particular questions? I'm checking the chat here. So
one question in chat that referred to the AI options, other AI options other than ChatGPT, because some industries or companies are not allowing folks to use ChatGPT.
Yeah, I just saw there's a secure one that is out there. And so, yeah, I'm not surprised people are a little worried. There is a way to take the ChatGPT technology, though, and apply it to a separate database and then have it be available only for that information. So, you know, we're very security conscious. We do a lot of work for the Department of Defense and Department of Energy. So we are in very high secure environments, as high as you can go in security. So, yeah, we're very cognizant of those kinds of issues, and anything we do will be absolutely meeting all the requirements.
I've been playing around with ChatGPT for requirements, and at first I thought it was kind of neat. I gave it some requirements, said what's wrong with them, and it identified some of the defects. But then I went in there and said, "Are you familiar with the guide to writing requirements?" And it said yes. And I said, "Okay, list the characteristics of well-formed requirements." And the list it gave me was not from the guide to writing requirements. It lied to me. And then it doesn't give you any reference to anything that tells you. And then I said, okay, rewrite some of these requirements to be better. And even though it identified defects in my requirements, the requirements you wrote were still very defective.
I'm sorry, just a comment about it lied, hence it's human.
It's very bad. And then you have BARD and some of those, and some of the tools I put in a requirement says the brake system shall stop the vehicle quickly.
Mm-hmm.
And some of the tools say, hey, that's a great requirement. There's so many things wrong with it, that
I know. Oh my gosh, yes, I know. And we found issues with our NLP checks as well. And this is why, like I say, I don't think I'll ever make the score be 100%, because if I do that, I know people will just say, okay, it must be perfect. The AI says it's perfect, so it's perfect. Well, that's of course nonsense, but unfortunately, that's a lot of people who do it. I see somebody who's asking about PhD student. Yeah, so it's available at innoslate.com. You just sign up for free, sign up with a .edu, and you will get an automatic update to the academic version. And we do make it available for free to students and academic use. We think it's very important. We also see it as a research tool. So again, we have open APIs. It's all cloud-based. So we're really kind of at that bleeding edge of the technology. And so we're always trying to keep ahead of that technology. That's why we're looking at things like ChatGPT. We do have a NASA project. It's a NASA STTR. We're in phase 2. Our research institution partner is George Mason University. And we've been doing some work in converting standard operating procedures into diagrams that then can be executed using our Monte Carlo simulator to look at the issues with the process itself. So that's another thing we are working towards.
Thank you. Thank you. That was a great response.
By the way, I think one of the things I like that keep saying that AI is not a mind, and I think as long as we keep that in our heads, it will help us a lot. And I think there's a lot of fear mongering going on about AI as well. I hear out there, and I don't quite understand it. There've been these waves of AI over the last, my lifetime. I've seen at least 3 cycles, and every time the hype curve gets really high, and then all of a sudden, boom. But we make improvements as we go. So does our AI work evaluating the set of requirements too? I think there's some of that in the sense that some of that's in our requirements analysis, but you have specific ones that I'm not sure we're covering as well as I want to. So even though they're using some of the same names, and I noticed that was again a thing, there's a same name for the characteristic for individual and for the set. And so I think some of that, like consistency and things like that, we are doing some of that check more globally, but I want to do that more rigorously. And I think your rule set gives us that opportunity. We were winging the other one. We had to make up the algorithms pretty much on our own using some of the NLP technology, but it needs a lot of work in my mind.
I had a question on your document view on the labels. Are those manually tagged, or does that come in as part of the imports?
So they are really manually tagged right now. So that is something we might be able to also use some NLP to look at for things. Yeah, can we distinguish between a performance requirement, a verification requirement, an environmental requirement, on and on? The different types of requirements. Maybe. Again, I think some of the things we could look for in there, particularly like environmental or safety requirements, might be able to be distinguished, and that would be something worthwhile pursuing. And again, we're very happy to work with people in terms of trying to how can we make those kind of improvements? What would be a good algorithm for making those kind of determinations? So yeah, please feel free. I believe we've also supplied this to organizations. I know AIAA is using it for some work we're doing there as a collaborative tool. We're supporting the ASME. They're building actually a facility standard in Innoslate for a new standard for them, and several other organizations. I believe we've offered it to INCOSE for the same purpose. So if there's something you see, oh gosh, your tool does a lot of what we want, but we'd like to do more. And I know what I didn't show you was the scheme editor to add things to it. So if you need to add to classes, you can come in and go to the requirement. Now, I believe this one, so these quality scores are made up and they're at the high level. So this would require administrator adjustment if you want to add to that quality score. And I happen to be an administrator of this organization, and so let's go there and navigate schema. There we go. So here's the schema editor up at this level. And now if I make changes, they will apply across the board. So looks like we've locked these though on the quality score. So I thought we could add to that. But anyway, we can certainly add to it, and it's something we are looking to do. So that has been part of our thing. I guess we just had a problem with that because the tool often depends upon certain information being there. And if it's not, then that's problematic. So any other questions?
Is there any kind of tag or reading on like TBD or TBC?
So actually it does. I thought we had a TBD check actually for that. You could easily put a label for that purpose. Of course, my goal is never to have TBDs. And one of the things we found is that oftentimes people go too deep with the requirements. There's too many requirements almost. It's a funny situation. What's the right number required? It's sort of like with modeling. When do you stop modeling? When do you stop decomposing? So this is always a struggle I think we have in our industry is, do we do too many? Are there too many of these things? It's a challenge. I think you all know the challenge.
Yes, I totally agree. And some of the stuff I'm doing for a case study, I'm talking about a robot that puts lids on a jar. My total set of system level requirements is like 49 requirements. And I think most organizations for that same robot at the system level, they would still write 400.
Yeah. Yeah, that's what I mean. It's stuff like that. You go, wait a minute, why? You're just making your job so much harder. And are you really going to get a better product out of that? I don't know. You know, this is the challenge with this. And particularly, one of the things that's I think been a problem for systems engineering is it's seen as such a bureaucratic activity. And it isn't, but that's the way it's viewed by so many people. It would be really nice to do things. So we're trying to put more agility into the overall process as well. So these tools, if they can help us do our job better and faster and cheaper, then I think the people will see more value in systems engineering. And that's really been our goal in its development. And we're a little different. So, and of course, I have to put the last slide up.
Well, if there's no further questions or comments, I think we could conclude this evening.
Well, thank you all. Appreciate the opportunity. If you have any questions, please contact me. It's just Stephen.Dam, SPEC Innovations.
Well, thank you very much.
All right.